Hi everyone, and welcome to this quick Godot tutorial where we're going to discover the power of 2D tilemaps. By the end of this tutorial, you'll know how to import, set up, and use tilemaps in Godot to quickly create sprite-based 2D levels with both visuals and collisions. As usual, don't forget that if you want to get the files of this tutorial directly, you can have a look at the GitHub repo with all my Godot tutorials over here. And with that said, let's dive in and explore Godot's 2D tilesets and tilemaps. First things first, let's quickly recap what a tileset and a tilemap is, and let's see where we can get some core resources for a quick demo example. In a nutshell, a tilemap is a grid of tiles, meaning that it's a big set of little sprites that are neatly organized in contiguous cells and altogether form a 2D level, or sometimes a pseudo 3D level with isometric render. Using a tilemap is usually way better than manually positioning sprites next to one another, cause it's way easier to edit, you can make a big area very quickly, you can replace sprites just by clicking over them, you can stack multiple layers to better organize your scene, etc. And it's also way more efficient. And because it's designed for groups of tiles, a tilemap can also handle collisions, occlusion, or navigation, for example. So, as we said, a tilemap is an actual level, with its particular shape, and probably a lot of repeated tiles. But a tilemap always depends on a reference tileset, which contains the sprites for each available tile just once. This is the reference atlas that the tilemap will go and pick from, and what's great is that it centralizes the data in one place, so you can then share this set of tiles with multiple tilemaps to create multiple consistent tilemaps that each correspond to a single level. Now, from a game creator's standpoint, a tileset is usually one big image, with numerous sprites stacked together as a grid. You can of course make your own. If you're curious, I highly recommend you watch Adam C. Innes' channel, who's great for 2D art, and in particular contains several videos about tilesets. But if you're like me, and you can't make any decent art, you might also want to find some free resources on the net, at least to try a few things and get you started. A famous ref here is the amazing Kenny library. This lib contains a wide variety of little packs, from audio files to 3D models, UI components, or 2D tilemaps. And everything is available under a CC0 license, so it's just great of them to share all of those resources. Feel free to browse the website and see which one you like the most. Here I'll be using the platformer art pack, which contains a lot of environment tiles, plus some neat characters with their own animations. So okay, let's say that you have a big tileset image, with all your sprites organized as a grid, and you've dragged it in your Godot project to import it. The next step is to set up a Godot TileSet object based on this image, to actually chop down the image into little tiles. To create a new tileset object in Godot, we can right-click in the file system doc and create a new resource of type tileset. You'll notice that as soon as you've saved your tileset resource, Godot opens a new panel at the bottom of the screen with tileset-specific editors. In particular, the left area is where you can add or drag your reference tileset image, so that Godot knows what to use as sprites. When you drag in the image, Godot will offer to auto-generate tiles, and you'll see that the right part is now filled with our tileset image and a grid of little cells overlaid on top. These cells are the sprites of our tileset that Godot auto-generated based on the default setup options we can see in the middle of the panel in the setup section. Now the issue is that if we zoom in, we clearly see that for now those tilesets don't really match our image. For example, the block in the top left corner is subdivided in 5 cells, instead of being just one single cell. That's because, depending on your reference image, you might need to adapt the size, the padding, and/or the margin of the tiles in your tileset resource so that they properly match the visuals. Otherwise, you'll basically end up with an unusable set of incomplete tiles that need to be reconstructed manually, and you'll lose all the benefits of a tilemap. Now, to be honest, finding the size of the cells, their padding and all, can require a bit of guessing. Sometimes you'll also have the tiles isolated in your reference pack, and in that case you can directly check the expected size of each tile as a separate image. But you might still need to test a few things until you've properly tweaked your tileset settings to match the image. In the specific case of Kenny's Platformer Art tileset image, the tiles are 70 pixels, and they're separated by 2 pixels in both the X and Y direction. If you have to change the size of the tiles, like here, don't forget to also change those values in the tileset resource itself in the inspector. Otherwise, you'll get some inconsistencies when you try to use this tileset in a tilemap further down the road. But anyway, you see that now, with those updated settings, the grid cells indeed match the sprites, and we're ready to actually use this tileset to make a particular tilemap and create our first sprite-based 2D level in Godot. With our tileset ready, it's now time to actually use it to paint a 2D level. This time, because it's scene dependent, we're not going to create a global project resource. A tilemap is a 2D node that lives in a Godot scene. So let's create a new 2D scene, and inside, add a tilemap 2D node. Now, in order for a node to know what tileset to use, we'll simply drag our tileset resource in its tileset field, and you see that now we have a new tab in the bottom panel for this specific tilemap, where Godot re-injected our pre-slide tileset. That's basically like a color palette, except that it's a sprite palette. By using the edition tools at the top, and by clicking on the various cells inside our reference tileset, we'll be able to paint, remove and modify tiles directly in our 2D scene to build our level. Actually, doing this is quite easy. Let's just click on one of the grass tiles in the set, for example, make sure we're using the paint tool over here, and move our mouse to the 2D scene above to start and paint our level. You see that there is an orange grid to help us place our tiles, and we just have to left-click to place a block. We can go and click on another tile in the set to quickly change the type of tile that we're painting, and we can even use Shift to select multiple tiles that are next to each other in the tileset image, and directly place both those tiles next to each other in our tilemap. If at any point you want to replace some tile with another, simply pick your new tile at the bottom and re-click on the old one to overwrite it. The Select tool allows you to select and move tiles that have already been placed. The Line tool lets you quickly draw a whole straight or diagonal of the same tile. The Rectangle tool does the same, but for a square zone. And finally, the Buckled Fill tool is useful to quickly fill areas that are either contiguous or just the remaining white spaces in the tilemap. Also, by default, a tilemap has one layer. But if you want to put some objects on different layers, either because you want them to visually overlap properly or because they should have different behaviors, for example, you can go to your tilemap node inspector panel, open the layers section and click Add Element. If you have multiple layers, just be careful when you're painting to pick the right layer in the tilemap bottom panel by using the drop-down over here. You can also show or hide a specific layer, and you can use the Modulate color field to apply a global tint on the tiles of a specific layer. Alright, all that's pretty cool, and we now have a great tool for setting up our 2D levels. But there's a problem. If I take a 2D rigid body and I place it just above my tilemap, as if it were a player subjected to gravity, for example, then when I run my game, you see that the object just goes right through the map. And that's because, for now, our tilemap doesn't have any collisions. To add physics to our tiles, we actually need to modify our tileset resource, because remember that this is the centralized reference that all tilemaps share. So this is where we define all the global data, such as tile collision. If we double-click on our tilemap resource to show its inspector, we see that there's a Physics Layers section. Let's click on the Add Element button inside, and you see that this creates a new layer with some specific physics collision and mask layers. But to really apply this collision layer to a tileset, we need to tell it which tiles use collision, and what the exact collision shape is if need be. So let's go back to the tileset editor again, and then let's switch the Pane section in the middle, and in the dropdown, choose our Physics layer. Now we just need to click on our various tiles to set collisions on each one. Note that if your tile is not a full square, the default collision shape probably won't match, so you'll need to readapt it a bit manually. To do this, just go to the small inspector in the middle, and in the zoomed-in view of the collider, just add, move or delete points to match the tile's visual. And that's it! You see that if we replay the game, the ball now falls and stops on the ground. So we've successfully made a very basic 2D level. Of course, there is still a lot more to learn about tilemaps, such as non-square tilesets, automatic navigation using terrains, or pre-made patterns. So if you're interested, don't hesitate to drop me a comment down below, and I might make a follow-up tutorial on those additional features. But anyway, here you go. You now know the basics of importing, creating and using 2D tilemaps in Godot. I hope you liked this tutorial and that it will help you create your own 2D levels. If you did, feel free to like the video and subscribe to the channel to not miss the next ones. And of course, feel free to leave a comment with ideas of Godot tricks that you'd like to learn. As always, thanks a lot for watching and take care.